Okay, Assalamualaikum and good morning or good afternoon to all of you. So next we continue on this new subchapter or our last subchapter in chapter 3, which is trapezoidal rule. Previously, we already discussed in our first hour on chapter 3. Uh, in order, our aim previously to approximate the roots by using interaction method. But this one, by using trapezoidal rule, we will approximate the area. Okay, because not all the function we can simply integrate. Because when we integrate, that one will represent the area, right? But not all the function we can simply integrate. So that's why we have to apply this trapezoidal rule in order to approximate the area. Okay. For example, when you need to integrate, okay, you need to find this area. Okay, area of this function f x equal to exponent x sine 2x, and then ln for x. It's a really complicated function, right? And then this one also you still do not learn during our last chapter. So no need lah to integrate this one. So we only use trapezoidal rule. Okay, at first, okay, for this question, because you already covered during your lecture, please revise your lecture note or look at, refer to YouTube. Okay, on this chapter, use a trapezoidal rule with 5 ordinates to approximate, okay, that function, and then using this definite integration, find the value of the integral. Compare the two answers and give a reason for the difference. Okay, so the first one is this one, 5 ordinates. First, you need to know what is the difference between ordinates, street, or interval, sub-interval. Okay, when it gives you 5 streets or 5 sub-interval, or sometimes 5 interval. So that means your n is equal to 5. But when it gives you 5 ordinates, so that means your n is equal to 5 minus 1, which is equal to 4. Okay? Because when you are trying to find the area, this area under the curve, and you will represent each of what we call it a trapezium. So this is first, second, third, fourth. Okay, so this one, okay, this is your first trapezium, second trapezium, third and fourth trapezium. So that's why your n is equal to 4. But your ordinate represent this one. First, second, third, fourth, and fifth. So that's why your ordinate here is 5. So here, okay, I'm writing our n is equal to 4 because it is 5 ordinates. Okay, next. Okay, what we're gonna do here? A second. Okay. What we're gonna do here? We need to know its fx. So its fx here is this function 1 over 1 plus x. And then, okay, we need to use, okay, at first we need to find our h. H is equal to b minus a over n. So our b here is this one, a to b. So this is a, this is b. So our b is 1, minus a is 0, over n is 4. So our h here is 0.25. So this is the first step we need to do. And then we need to construct our own table by using calculator. Okay, okay, this is new calculator. I think your lecturer during your lecture already teach you. So first, press menu, and then actually I still don't know lah about this one. So I think you need to choose 8. Okay, number 8 ini spreadsheet. 8. Oh, not this one. Uh, saya pun sebenarnya tak tahu sangat ni sebab previously guna yang lain. I think 9 kot, table. Yes, good, 9. Okay, press 9, table, and then substitute our function, which is fraction 1 over 1 plus x, alpha x. And then press equal, or gx, no gx. And then start from A. Our A here is what? Our A is 0. And then our B is 1. Our start is our H. H is a 0.25. Okay, and then press equal. So you get your own table. Okay, so after you get your own table, just rewrite here. Okay, it's really important for you to rewrite. So put here your xn, and then here is yn. Okay, for xn here, okay, look at your value from your calculator, begin from 0, and then 0.25. Okay, and then 0.5. The last one, sorry, 0.75. And then the last one is 1. Okay, and then the next one here, you have to divide this table on yn. Okay, first put here our first value is 1, and then our last value. So our last value is 0.5. Okay, put on the first table. Okay, on the second table, we will write the rest, which is when x equal to 0.25, 0.8, and then 0.667, and then 0.5714, and lastly is a 0.5, that one. Okay, it depends on the question. Okay, let's say here the question state up to 3 decimal places. So that's why we always list more than 1 decimal places. So 0, 0. Ini 1.0000000. Okay, so here will be 2 values. The first one, you will sum up this, the first and the last value here. So it will be 1.5000. And this one, okay, calculate. Okay, this one, I think you need to clear. After you clear, you will have sum up together here. After you clear your calculator and then sum up together here, you will have 2.0381. Okay, lastly, so after you construct your own table like this, okay, we are using a correct formula of trapezoidal rule, which is this area equal to h over 2, and then y0 plus yn plus 2 y1 plus y2 plus macam ni lah. Okay. So this one, okay, our h here, okay, our h here is a 0.25 over 2, and then our y0 plus y1 is this one. This one, 1.5000. Okay, and then plus 2 bracket, our next value, the rest here will be this one, 2.0381. 2.0381, simple. And then after you calculate, you have here 0.5724. Okay, 3 decimal places is 0.572. Simple. Okay, next. Okay, this one I already solved by using trapezoidal rule. Next, I'm going to show you for definite integral here. Okay, this one, definite integral. Okay, when it comes to definite integral, we need to integrate this from 0 to 1, and the function is 1 over 1 plus x dx. So it will be equal to what? Ln 1 plus x, and then from 0 to 1. So after you substitute, it will be ln 2 minus ln 1. So by using calculator, you will have here 0.693. And then when you calculate the difference here, so calculate the difference. So it will be 0.693 minus 0.572. So what we get here? For a second, 0.693 minus 0.572. So you will have here 0.121. I think that's a bit different here. Perbezaan yang ketara. So what you have to comment about this one? Okay, basically it's due to actually this is your actual area. I forget to explain, this is actual area, and this one is approximate area. So obviously this is our actual area lah. Okay, the real area. Okay, so since this is too much different between approximate and actual area, so we have to comment because of what reason? Okay, because of this one and is equal to 4. Okay, there are only 4 trapezium here. So in order to increase what we call it, accuracy, we need to increase number of trapezium. Okay, then the accuracy will also increase, or the error. Okay, the error also the error will decrease. So how to calculate the error? So the error is this one. So I'm gonna show you how to calculate the percentage error. Okay, so the percentage error equal to absolute or modulus actual minus approximate, and then over actual times 100. So here you already have the difference is actual minus approximate is 0.121 over actual is a 0.693, and then times 100. So this is your percentage error, 0.121 over 0.693, and then times 100. So your percentage error is to beat here, so it is a 70.5%. Okay, usually the accurate area when we approximate by using trapezium, the percentage error must be less than maybe 2%, 1%. So how? We have to increase the number of trapezium or number of n here. Okay? So I think that's all for our trapezoidal rule. Okay, you need to do some exercise in order to make it deeper understanding in this subchapter. Okay, that's all. Thank you.